Greetings! This video will show how two-dimensional grid models and three-dimensional block models are used by Rockworks to perform volumetric estimations. Here's how it works. Let's start with a two-dimensional example. We begin with a grid model in which the node values represent sand thicknesses as estimated by a gridding algorithm. If the grid node spacing is 50 meters in both the X and Y directions, then the cell area is equal to the width times the height, or 2,500 square meters. Given that the volume of a parallelepiped is equal to its length times its width times its height, we can easily determine the volume of material represented by each cell. In this example, we multiply the length, 50 meters, by the width, also 50 meters, by the height, 7 meters, to get a volume of 17,500 cubic meters for this one particular cell. If we sum all of the node values and multiply by the cell area, we get the total sand volume. In this example, the sum of all node values is 272 meters. So we multiply this number by 2,500 square meters, the area of each cell, to get a total sand volume of 680,000 cubic meters. To convert from volume to mass, we multiply the total volume by a density conversion factor. In this case, we take the volume of 680,000 cubic meters and multiply it by a conversion factor of 1.826 tons per cubic meter, and the result is 1.2 million tons of sand. In case you haven't noticed yet, this is some pretty simple stuff. Models are converted to volumes and masses via some straightforward addition and multiplication. Let's throw in a slight twist by pretending that we're only interested in the areas where the sand thickness is greater than 5 meters. A simple low-stop, high-pass filter is used to remove the nodes where the predicted thickness is less than 5 meters. If we use the previous equation with this filtered grid model, the mass drops from 1.2 million tons to 0.8 million tons. Let's review the mass computation. Mass equals the sum of all thickness nodes times the cell area times the density factor. Now let's move on to a three-dimensional example. We begin with a block or solid model in which the node values represent TCE, or trichloroethylene, concentrations as estimated by a 3D interpolation algorithm. The volume of each voxel or volumetric element within a block model is equal to its length times its width times its height. In this example, the horizontal node spacing is 5 meters and the vertical spacing is 3 meters. Therefore, the voxel volume is 75 cubic meters. Now, let's use the same type of low-stop, high-pass filter that we use for the two-dimensional sand thickness example to remove all of the voxels in which the TCE concentrations are less than 0.7 parts per million. Unlike the two-dimensional thickness volumetrics, the block model is converted to a volume by counting the number of nodes that exceed a cutoff value, 0.7 ppm in this case, and then multiplying the result by the voxel volume. The volume represented by this contaminant is roughly 50,000 cubic meters. To convert a volume to mass, just multiply the volume by a density conversion factor. In this case, we end up with 91,000 tons of contaminated material. Thanks for watching.